I wanted to as well review how we determine the safety and viability of our ventilation operation. That was something that we had discussed in class when the roof officer is determining the safety and viability of his operation. What are we doing and why are we doing it? How do I determine if this roof is safe? The incident commander asks for a roof can. What is your conditions, your actions, and your needs? Really what he's trying to get out of that roof officer is determining the safety and viability of that operation on the roof, and concurrently the safety and viability operation he has going on under that roof. If our roof is not safe for us, one of the main concepts we have introduced, if it's not safe for us, it is not safe for the people that are below us. So really what that incident commander is trying to get out of us is determining the safety of our operation. And the way that we have a tool to relay that to him is the formula of truss span, burn time, fire load, risk versus gain, and percent of building involvement. So what we're looking at in truss span is what is our representative span of the members we're standing on, whether we're standing on wall-to-wall truss, whether we're standing on a conventionally constructed flat roof with multiple interior load-bearing walls or panelized roof construction. Is this member's distance is relative to its strength as well as its dimension. So we're not only looking at the truss spans, we're looking at the representative dimension of that span. And that determines for us our initial safety and viability of that operation. The longer the member span is and the smaller that it is, inherently the weaker it will be. As well as the distance in which they are far apart from one another. So in a 2x12, 12-inch on center roof with 1x6 decking, our representative roof construction allows us to be slightly more aggressive over the seat of the fire based on the fact that that truss span and the dimension of the lumber and their proximity to one another are so close that it allows us to become more aggressive. Now, conversely, we take a 8-foot on center wall-to-wall truss span roof that's 85 foot of unsupported span, open web metal bar joist with increase in surface area over that open web metal bar joist surface, 85 foot unsupported spans, and the distance in which those are apart. That roof now is inherently more unstable in fire conditions. Doesn't mean that that roof is unstable and unventilatable, but what that does mean for us is that we have to trade space and time. We have to change and modify our tactics based on known factors. We cannot take the same tactics that we would have taken to the 2x12 roof and implement them on the 8-foot on center open web metal bar joist roof. So the very first step in determining that safety and viability of the operation is determining our building construction and its representative strengths and weaknesses. Then we want to look at the burn time, representative of a 3 and 3 rule, 3 a.m. and 3 p.m. Well, how long has this fire been going? How long has it been seated? A 3 a.m. fire in a downtown area, a deep-seated fire in a commercial building, potentially has been burning in our plenum space, our open spaces, the roof spaces we're going to be walking on for quite some time. And we need to be very cautious to make sure that we assess the burn time of this building. We read that based on the smokes, color, pressure, density, the volume of smoke, the amount of smoke we have coming out of a building, the time of day, and so on and so forth. We then look at fire load. That's representative of what they're doing business as. Each building inherently has different continuities of fuels, fire spread travel from the C side to the A side based on what they're doing business as well as what the products of the combustion process will produce, how much smoke, at what volume of smoke. And an example of that would be starting one pallet of tires on fire in the center of a giant building will produce a lot of smoke. The heat on that will be a good heat, but not a super hot heat, and the continuity of that smoke will be massive. However, in let's say a Radio Shack, the continuities of the fuels and the burning of the fuels and the A side of the structure will not be as plentiful. It's really just representative of what they're doing business as and how much smoke I'm anticipating having. Is this cold smoke or hot smoke? We then assess risk versus gain. This is something that I think is imperative to take the previous 3 assessments and really kind of put them all together and fully understand what is our representative risk versus gain. Center hall dwellings at 3 o'clock in the morning, our risk versus gain assessment tells us that we need to be very aggressive over the seat of that fire. We are risking a lot to save a lot. Now, that does not mean that we should push ourselves into a position in which we become risk victims, but that does mean that we are risking a lot to save a lot. We're not going to trade a lot of space and time. Conversely, in a building that's abandoned at 3 o'clock in the morning in the downtown area, our risk versus gain assessment on that building is not conducive for us to be very aggressive over the seat of the fire. Trade space and time. It's not a great risk or it's not a great gain for us to push forth a lot of risk. And then percent of building involvement. How much of this building is on fire and what is on fire? Is the building on fire or is what we're standing on fire? And how long has it been on fire and how much of it is on fire? It's very, very important for us to really take that answer of risk versus gain and an assessment of how much has been burning and the truss spans and the burn time and the fire load, and really come up with a one sentence answer in our CAN report for what our current conditions are to that incident commander. And really all he wants to know is this is a good roof or a bad roof? Yes, Chief, we have a very good roof. We are on a 2x12, 12-on center roof with good fire conditions. We are maintaining offensive operations and we need one additional truck. The portion of that he is principally concerned about is this roof a safe roof for you to be operating on, and is it a safe roof for me to be putting people under? That is really the assessment of our truss span, burn time, fire load, risk versus gain, and percent of building involvement. Is really taking something that is very difficult for us to explain and taking it and making it something that is very difficult for us based on our experience to determine the safety of an operation, the viability of an operation without having to base solely on experience.